In this video, we're going to be talking about sets. Now, there's going to be a lot of terminology here. So number one, you got to get to know the vocabulary that we use with sets. And really what we're doing is forming a foundation for what we're going to do in logic. And also there's a little bit of probability that we do where sets can kind of help you to see some things. And so with that being said, let's get started. I'm going to start by doing something where we can have a little bit of fun. So this intro says, what do the following have in common? Number one, grass, ball, hole, club, tiger. Hopefully by now you're all thinking golf. Number two, football, school, Halloween, World Series. If those didn't get it, this one might. Leaves. These are all associated with fall. Number three, archer, violinist, gift. Now this one's a little tougher. These are all things associated with bows. Number four, April, locker room, bride-to-be. These are all things associated with showers. All right, last one. This is another tough one. Bowling alley, tailor, wrestling match. What was I trying to get you to say? Pins. So it mentions here it's human nature to organize, categorize, and classify. Putting things in sets helps us to organize and simplify our world, where we deal with a great amount of information. That's never been more true. All to say, it's like human nature. Well, I mean, that's what it's saying here. I think of when I used to go trick-or-treating. I'd come home at the end of the night, I'd pour my bag out, and I started putting my suckers together, my gum together. And then once I got it all organized, I would make trades with my brother and my sister. And so anyway, some of us are definitely more organized than others, but we all tend to be that way. Let's talk about the language of sets. So a set is a collection of objects, each of which is called an element, or we use the word member. I'm going to stress the word element, and you'll see why in a second, or a few seconds here. So let's look at a couple examples here. The students in this course would be a set of objects or people, and one more, the days of the week. A set is well defined if its contents can be clearly determined. So that's what we mean by well defined. So the college campuses that are part of Dallas College, there are 7 of those, and one of those is Brookhaven. But that's well defined. We all know what 7 they are. If you don't know them, you can go online and you can see. Give me something or an example of something that's not well defined. How about the 3 best movies this year? In fact, I would guess most of us would choose 3 different movies. Certainly a lot of us. This is an opinion. It's not well defined by any stretch. All right, let's move on to the next slide. Now, it's common to describe sets in 3 ways, and we're going to be using 3. The first one is words, so an example would be the Three Stooges. By the way, do you know who they are? If you don't, you're going to have a chance in just a minute to if you hopefully at least know 1 or 2 of them. And then let me give you one more example, the seasons of the year. Roster form, it says list the elements in braces. So we can use a word description or we can use roster form. Now this is what we mean by braces. And so an example would be Larry, Curly, Moe. Those are the Three Stooges. The seasons of the year, winter, spring, summer, fall. So this is what we call roster form. All right, so we're going to practice just a little bit before we move on to the third way. It says express each of the following in roster form. Number 1, set A is the set of natural numbers less than or equal to 50. So the natural numbers are what we sometimes call the counting numbers, 1, 2, 3, 4, and so on. So we want the ones that are less than or equal to 50. So 1, 2, 3. Now we don't want to write them all out up to 50. And so what we do is we'll put 3 dots. We call this an ellipsis. And then we'll put 50 in. And so that's how we would indicate all the numbers that are either less than or equal to 50. And they're also natural numbers. Number 2, the set of natural numbers between 2 and 7. Now you got to be careful with that word between. For some of us, that word means something a little different than it does for others. Normally when we say between, we're not counting what's on the end. And so this would be the numbers 3, 4, 5, and 6. And that's how we would, that would be the meaning here in math. All right, number 3, the set of even natural numbers between 200 and 300. Now, one of the things you have to be careful of when you take this next test is that you read carefully. It does say even natural numbers, and it does say between, so we won't count 200 and 300. All right, so we're going to have 202, 204, 206. Notice that I did my ellipsis. So we normally do 3 numbers, and then a comma, and then our last number. All right, let's move on to the next slide. So the symbol that looks like this, it's kind of like an E, is used to indicate membership in a set. Now remember, I said the items in the set are called either elements or members. And so we're using E for element, basically. That's why I'll tend to focus on the word element. But member is another word that we use for to indicate membership. The symbol, that's this one here, which means not an element of, is used to indicate that an object is not a member of a set. So here's an example of that. If we have the set A that consists of the numbers, natural numbers from 1 to 30, then the following are both true. 2 is an element of A. Well, 2 is in that set. B, 31 is not an element of A. So 31 is bigger than 30. It's not in the set. That's how we indicate it. Number 3, set builder notation. So this is the third of the 3 ways that we write sets. Notice it says set builder notation is commonly used in algebra. So let's, yeah, I know some of you are like, not algebra, but that's okay. We're not going to go too deep here in algebra. But you do need to be familiar with set builder notation. So let me give you an example. This is a set that's written in set builder notation. How do you read this? Well, A is the set of elements such that X is a day of the week. So A is or equals the set of elements X such that X is a day of the week. So that's how it works. All right, and after looking at this one, you might be thinking, man, that just seems kind of goofy. Why don't we just say the days of the week? And I would agree. We tend to, this form tends to be a little bit more useful when we are dealing with things that are algebraic. So an example here would be B. B is equal to the set of elements X such that X is an element of N, the natural numbers, and X is greater or equal to 8. All right, so if you wanted to write that in roster notation, it would look like this. 8, 9, 10, and then we'll do that comma and dot, dot, dot. So those are the numbers basically greater or equal to 8. And keep in mind, they're also natural numbers. There's a lot of numbers greater than or equal to 8, and we're not including all of them. We're only talking about natural numbers here. Like, for example, 8.5, that's not a natural number. All right, so I would encourage you to try numbers 1 through 4 and then watch the video to see how you did. All right, so there's number 1, the set of elements X such that X is a season of the year. Number 2, the color of the American flag, well, that would be red, white, and blue. Number 3, so these are natural numbers, and notice if you read this backwards, this is actually red. X is greater than 3. If I read it from left to right, I say 3 is less than X. But we have X is greater than 3, and at the same time we could say X is less than or equal to 10. X is both. Basically the idea is X is between 3 and 10, not including the 3, but including the 10. And so that would be these numbers here, 4 through 10. Number 4, true or false. If A is equal to the set of elements X such that X is an element of n, the natural numbers, and X is odd, then 3 is an element of A. Well, that's true because 3 is odd. And 8 is not an element of A. Well, that's also true because 8 is actually even. All right, so this is true. In order for this statement to be true, both of those would have to be true. 3 is an element of A, and 8 is not an element of A. They're both true, so the statement is true. All right, let's move on to our last slide. A set is said to be finite if it contains no elements or the number of elements in the set is a natural number. A set that is not finite is, well, it's called infinite. So here's an example, a couple of examples. So if A is A, E, I, O, and U, that set of, it's actually the vowels, right? Then we would say that A is finite. In fact, there are 5 elements in the set, so we can name it, or we can name the number of elements using a natural number. Another way to say that is the elements are countable. There's 5 of them. An example of an infinite set would be the odd natural numbers. So again, that's infinite. If you were to write it, it would look like this. 1, 3, 5. Notice these are odds. And then dot, 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 indicating they go on forever. There aren't a set number of odd natural numbers. We cannot count them. They go on forever. And so this is an infinite set. All right. It says 2 sets are said to be equal if they contain the same elements. 2 sets are said to be equivalent if they contain the same number of elements. Now you got to be careful here because in some situations in math, you might think of these words as pretty much being the same or having essentially the same meaning. That's not true here. So let me show you. Read that again and make sure that makes sense to you that these are 2 different things. So an example, if I have the sets with 1, 2, and 3, that would be my set A, and B has 3, 2, 1, and 1, well, aren't those the same elements? A and B just have 1, 2, and 3. It doesn't matter that the order in B is different. It doesn't matter that I wrote the 1 twice. It's still the same set of numbers, 1, 2, and 3. And so we would say A and B are equal sets. They contain the same elements. All right, let me go ahead and add C. It's the set with Larry, Curly, Moe. So it's again our 3 stooges. And so we could say that A is equivalent to C. Now, it's also true that A is equivalent to B, but it's a little bit more obvious and clear that A is equivalent to C. They have the same number of elements. All right. Keep in mind in B, we don't really count the 1 twice. It's a 1 in the set, and you don't need to, how many times you write it makes no difference. All right, so the next thing I want to talk about here, the cardinal number of a set. Sounds kind of sophisticated, but it's really not. It's symbolized by this. It's in parentheses A, with a big capital A inside. The cardinal number of a set, in fact, I should say of a set A, symbolized by this n with parentheses next to A, is the number of elements in set A. That's all it is. It tells you how many elements are in the set. So for example, if A is the set with winter, spring, summer, and fall in it, then the number of elements in the set A is 4. Or we would say the cardinal number of set A is 4. All right, last here it says the set that contains no elements is called and that would be called the empty set or the null set. And we symbolize it two different ways. We can use braces with nothing inside, or we can use this symbol here, which also stands for the set that contains no elements or the empty set. All right, that's it for this video.